Hello student, today I will start a new topic is chromatography. Okay, so in this lecture I will discuss about chromatography, what is chromatography, its principal types and application. Okay, now see the introduction of chromatography, that is what is chromatography. Chromatography is a physical process where the components of a sample mixture are separated as a result of their differential distribution between stationary and mobile phases. Chromatography, Greek word chroma meaning color and graphene meaning writing. Okay, means to write. Okay, so chromatography is the collective term for a set of laboratory techniques for the separation of mixtures. The mixtures is dissolved in a fluid called the mobile phase, which carries it through a structure holding another material called the stationary phase. The various constituents of the mixture travel at different speeds, causing them to separate. The separation is based on differential partitioning between the mobile and stationary phases. Okay, so this is the chromatography. So chromatography is basically the collective term for a set of laboratory techniques for the separation of mixtures. The mixture is dissolved in a fluid. This fluid is called the mobile phase, which carries it through a structure holding another material called the stationary phase. The various constituents of the mixture travel at different speeds, causing them to separate. The separation is based on differential partitioning between the mobile and stationary phase. Okay. Chromatography, literally color writing, was first employed by Russian scientist Mikhail Tissuet in 1900. Okay. He continued to work with chromatography in the first decade of the 20th century, primarily for the separation of plant pigments such as chlorophyll, carotenes and xanthophylls. Okay, since these components have different colors like green, orange and yellow respectively, they have the technique its name. Okay, so Russian scientist Tissuet have developed the principle of chromatography. Now see the principle. Chromatography usually consists of mobile phase and stationary phase. The mobile phase refers to the mixture of substances to be separated, dissolved in a liquid or a gas. The stationary phase is a porous solid matrix through which the sample contained in the mobile phase percolates. The interaction between the mobile phase and the stationary phase result in the separation of the compound from the mixture. Now see what is chromatogram. A graphical presentation of detector response, concentration of analyte in the effluent or other quantity used as a measure of effluent concentration. Okay, the retention time or volume is when a solute exits the injector and passes through the column and the detector. Okay, data represented by the chromatogram are used to help identify and quantify the solute, that means components. So chromatogram is basically a graphical representation of detector response. Okay, because eluting solutes are displayed graphically as a series of peaks. They are frequently referred to as chromatographic peak. These peaks are described in terms of peak 1 with these peaks are described in terms of, suppose one is peak width, second is peak height, third is peak area. So depend on these three characteristics of the peak, we identify the solute. Okay, now see the classification. Okay, chromatographic methods can be classified in three different ways. First is based on the shape of chromatographic bed. As an example, planar and column chromatography. So if chromatography are classified based on the shape of the chromatographic beds, then there are two types. One is planar chromatography, second one is column chromatography. If the classification based on the physical state of mobile and stationary phase, then there are two chromatography. One is gas chromatography, second is liquid chromatography. If their classification based on mechanism of separation, then the chromatography are ion exchange chromatography, partition chromatography, affinity chromatography, and adsorption chromatography. Okay, so chromatographic methods can be classified in three different ways. The three different ways based on the shape of chromatographic beds. So, this is one classification. Second is based on the physical state of mobile and stationary phase. Third is based on the mechanism of separation. Okay, now based on shape of chromatographic beds, chromatography are planar chromatography and column chromatography. Okay, this planar chromatography is again classified in paper and thin layer chromatography, and column chromatography further classified in gas chromatography and liquid chromatography. Okay, now we see planar chromatography. So now we will discuss about planar chromatography. In planar chromatography, stationary phase is present on a plane. The plane can be a paper impregnated by a substance acting as a stationary phase, paper chromatography, or a thin layer of a substance acting as a stationary phase spread on a glass, metal, or plastic plate, and this is called thin layer chromatography. Okay, so the plane can be paper impregnated by a substance acting as a stationary phase. This is called paper chromatography. Okay, and or a thin layer of a substance acting as a stationary phase spread on a glass, metal, or plastic plate, then it is called thin layer chromatography. Okay, planar chromatography is also termed as open bed chromatography. Now see paper chromatography. What is paper chromatography? Paper chromatography is a liquid partition chromatography. Okay, so paper chromatography is a liquid partition chromatography. In paper chromatography, the end of the paper is dipped in solvent mixture consisting of aqueous and organic components. The solvent soaks in paper by capillary action because of fibrous nature of paper. The aqueous component of the solvent binds to the cellulose paper and thereby forms stationary phase with it. The organic component of the solvent binds continues migrating, okay, thus forming the mobile phase. Now see the principle of paper chromatography. The principle of separation is mainly partition rather than adsorption. The Whatman filter paper is used as stationary phase. It is made of 99% of cellulose. Cellulose is very good adsorbent and it absorbs atmospheric moisture. The moisture develops as thin film of liquid on the surface of the filter paper, and this behaves as stationary liquid. Instead of water as stationary phase, other organic solvents can be used by suitable modification. Mobile phase. Mobile phase is basically organic solvent or mixture of organic solvent, and buffers are used. It is also called moving liquid or development solvent. The distribution of analyte takes place between stationary phase, that means aqueous phase, and mobile liquid, that means organic phase, hence called partition paper chromatography. So in this technique, a drop of the test solution is applied as a small spot on a filter paper, and the spot is dried. The paper is kept in a closed chamber, and the edge of the filter paper is dipped into a solvent called development solvent. Now the development solvent moves against the gravitational force upwards by capillary action of filter paper. The minute pores present in the stationary phase will provide the capillary action. When the solvent reaches the spot, mixture of two or more substances. Okay, so when the solvent reaches the spot, the various substances are moved by solvent system at various speed, and the solvent is allowed to move up to 3/4 of the paper, then stopped. Okay. This process of movement of mobile phase and separation of analyte mixture is called development process. Now the paper is dried and various spots are visualized by suitable detection process. So in this way, paper chromatography. So this is the principle of paper chromatography. Okay. So in this way, paper chromatography works. Okay. Now see the significance of paper chromatography. So paper chromatography is very easy, simple, rapid and highly efficient method of separation. It can be applied even in micrograms quantities of the sample. It can also be used for the separation of a wide variety of material like amino acid, glycoside, and pyrimidines, steroids, vitamins, and alkaloids like penicillin, tetracycline, etc. Okay. Now, in the next lecture, we will see thin layer chromatography. How thin layer chromatography works, what is the working principle of thin layer chromatography. Okay.